page 298 of your student journal is 9.5, quadratic formula. You also see a term up there called the discriminant. We'll see what that has to do with the quadratic formula. If you have never had experience with the quadratic formula, it is listed right here. We're not going to go through and actually prove it, but there's a way to come up with that formula using completing the square, but we're not going to do that right now. All right? So, this is just another way of solving a quadratic equation. So if you turn to page 299, take a look at that. On that page, you have listed all the different methods that we've used to solve quadratics and the lesson you can find them in your textbook. Okay, factoring. All right, has some advantages and disadvantages. For those of you who like factoring, I can't remember what that is. Remember, that's your parentheses. You're setting equal to 0. And then you solve. Okay, graphing, where you're actually seeing a picture form of how your quadratic crosses the x-axis. Okay, so if you think of it that way, those are your solutions where it crosses there and there. Square roots. Square roots are helpful when you do not have a middle term. So if you think of your standard form of a quadratic equation, ax squared plus bx plus c, okay, when you are without the b term, it's very useful to just use square roots. If you just have ax squared plus c. So that b term's gone. They call it d. That's when you move it over. But all right. Completing the square. Helpful if you have a is 1. So if there's not a number in front of x squared, and b is an even number, you could use completing the square. That's what we've been doing the last couple days. Quadratic formula takes some time, but it can be used on every quadratic to either solve or come up with the answer if no solution. Take it out, please. Okay? So, it's up to you which one you use. All right? I have preferences. When I'm solving, I always look here. Does it have a b term? If it doesn't, I go to square roots. If it has a b term, I then try factoring. And if it doesn't factor, I usually jump to quadratic formula. Sometimes completing the square, but I usually jump to quadratic formula. Okay? If I can get completing the square in really fast, maybe in this case right here, I might do it. But quadratic formula, if you're like, I can't remember most of these things, quadratic formula will work on every one of them. So if there's one that you want to learn so that you can just solve for x when you're given an equation with an x squared in it, you want to learn the quadratic formula. It's not the fastest. It won't help you with certain other areas of math, but it'll definitely help you solve for x. Okay? Quadratic formula is, on the previous page there, this big formula right there. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You ever heard the song Pop Goes the Weasel? Anyone ever seen Elf? Where he's like doing that and then it like freaks him out. He's like, oh, it didn't pop, and then it pops. That's one of my favorite scenes in Elf. Okay. But that right there, you'll hear some people, Kai, lean forward. You'll hear some people, don't be that Kai, be the other Kai that leans forward. There you go. Way to be that Kai. All right. Okay? The opposite of b plus or minus square root of b squared minus 4ac all over 2a. You can do the Pop Goes the Weasel to that. Now, I don't sing that too often. If you really want to get a good one, you could do nope, I can't do it again. But it's probably online. I'm recording, so it's online. Okay? All right. Hey, in order to use this, you have to have your equation in this format. We call that standard form, right? So if it's in standard form, you can use this formula. Now, once again, it takes a while. So it's very helpful to know whether or not you can actually complete the formula. There are times when you start this and you get towards the end and you're like, it doesn't even work. I can't even get an answer. I did all that work. I've got like a chunk of my page designated to work, and I've just found out that this doesn't even work. It gave me a no solution. Okay? Remember our solutions? we're looking at these pictures. This has two solutions. This has one solution. This is a no solution. Well, think about square roots. Okay, this formula right here has a big square root in it. So if we just isolate this chunk of the formula, okay, what would make that chunk of a formula be undefined or a no solution? What would have to be inside of a square root symbol? Yeah. You get a negative number in there, then you can't do it. Okay? If you get a positive number, you're good to go. But if you get a negative number, you can't do it. Positive number, you're going to have two solutions. How? Because there's a plus minus in front. It means there's going to be two pieces to it. Okay? Well, what would happen if you got a 0 in there? What's the square root of 0?
0.
It's 0. Okay, well, you would have that plus minus 0. When you add and subtract 0, add or subtract 0, does anything change? No. How many solutions are you going to get with that? 1. You're going to get one solution. Okay, so really it's important for us to know what's inside that radical. And what is inside there? Well, this is inside there. This b squared minus 4ac. So it's very important for us to take the b squared minus 4ac, which is what's inside there on each of those, and know what it equals. If it equals a negative, you're going to get no solution. So if you just do that really quick in your head and say, dude, that's negative, that's a no solution, then you don't do the rest of the formula. Just write no solution. If you do it really quick in your head and it's positive, you're like, oh, well, I guess I have to keep going. If you do it really quick in your head and you get 0, well, then you know that that part of the formula is gone. Now, note, if that part of the formula is gone, what are you left with? Negative b over 2a. What is negative b over 2a called? That's the x value of our vertex. So if this equals 0, you haven't moved off the y-axis. That's just your answer, whatever negative b over 2a is. That becomes your one solution. Okay? This thing right here is called the discriminant. And it's listed down here as well. Okay? This is the discriminant. I always think that I have one too many n's in there. Okay. The discriminant. The discriminant just helps you determine how many solutions there are. And please note that the square root symbol is not part of the discriminant. I was trying to make a point that you can't have a root of a negative. It's just this piece. It's the b squared minus 4ac. So if that's bigger than 0, meaning it's a positive amount, it's two solutions. So mathematically, we write that as it's greater than 0. If it's less than 0, so we write it like that, then it's no solution. If it's negative, that just means it's negative. Okay, and if it actually equals 0, that's our one solution situation. Okay, so you should start putting all these things together in your head, like, hey, two solutions right here, my picture is going to look like this. One solution is going to look like that. 0 solutions, it's that. It's a parabola. Okay? And then when you get to advanced algebra, you'll start studying what are called imaginary solutions, and that's what happens here. Okay, imaginary numbers. But we'll deal with that another time. Yep, junior year. Okay, so what I want you to do is down over on page 299 where it says notes, I want you to write out the quadratic formula, please. Just right up here. So you have it ready to go.
Do you know when you take math classes that pertain to the job you want to take?
They do. It's called college.
In school. Like throughout your
College is a school.
No, like throughout high school and middle school.
Well, you have to know prerequisite skills in order to take a lot of those courses. So if they waited till college to teach you all that stuff, then you'd be taking a lot of classes, paying a lot of money. You don't have a lot of prerequisites.
Want to do something else when you're older, like you choose when you're younger.
Yeah,
And then you
very,
want to do something else on your own.
that's a good
She's
point.
smart.
Yeah, she is smart. She's pretty smartical. Okay.
My God, you can't say that.
All right. There we've got it. So solve the equation using quadratic formula. Round your solutions to the nearest tenth if necessary. Okay. Here's what I'd like you to do. First thing, we are going to start with problem number, I don't know if it's going to be 1. I wrote down the problems. Let me tell you real quick. Start with problem number 1. Okay? So on problem number 1, I want you to list, first thing you need to do is list A, B, and C. Okay? 10 seconds. List A, B, C. Okay, we get what?
1, negative 10, and 16.
Good. 1, negative 10, and 16. A, B, C. Okay? All right. So we need A, B, C so we can plug it into these pieces. Now, please note how I do this. All you working ahead, just stop for a minute. So I will show you a surefire way that will help you to not make any mistakes when you do this. This way will take you just like a second longer than it would the other way. Okay? So when you're doing this, first I'm going to start over here because I want to have a lot of room. I am going to put negative and parentheses. Plus, minus, the square root of, parentheses. I ran out of room already. Unbelievable. Okay? Let me be down here. What am I putting parentheses for? What tells me to put a parenthesis? Yeah. Every time there's a letter, I put a set of parentheses. Okay? Now, just working with middle schoolers and high schoolers for the last nearly 20 years, I know that some of you will think that is a complete waste of your time and it does not apply to you. If that is the case, which is fine, some of you are going to do just fine not doing that. But I will tell you that there are some common mistakes that happen in here. First, when you do the opposite of B, if B is negative, you've got to have a negative 10 there. And a negative 10 is a positive 10. So when we say the opposite of B, some of you look at that and go, oh, that's just positive 10. Some of you won't do that. You'll have a harder time with that. So it's helpful to see the negative 10. What type you are, I have no idea. I can guess, but you really know if you'll make that mistake. Some of you won't start by doing this, and then you'll make the mistake 4 or 5 times. It's called learning the hard way. And then you will do it this way. Okay? So that's negative 10. And then the next place the mistake will be made is right here. Because negative 10 squared is 100. Well, so you're like, well, 10 squared is 100. That's true. But some of you will put this into your calculator as negative 10 squared. And we always believe our calculator, like it's always right. So I go negative 10 squared. And you're like, whoa, McCoy was lying. Negative 10 squared is actually negative 100. In fact, all my math teachers my whole life have lied to me. Okay? And it's not true. You've got to put parentheses. Right? It's 100. Your calculator reads this as 10 squared times negative 1. You have a programming error. So you're like, my calculator said it's this. No, you programmed it wrong. Whose fault is that? Yours. Yeah, you did. Okay? So that's why I like the parentheses. It's important. Plus, in math, we always substitute using parentheses. A is 1. C is 16. All over 2A. Okay. Now, what I do is I quickly calculate the discriminant. So I quickly go through this part of it. That's 100. Here I have 64. Well, 100 minus 64 is
36.
36. Well, one piece is just saying, hey, I have 100, I have 64. Am I going to get a positive or negative? If I have 100, I'm taking away 64, positive or negative? Positive. Therefore, you have to keep going. If you say, hey, that's negative, you're done. You just write no solution. That's the shortcut, right? That's why you do the discriminant first. If you do all that math, you're like, whoa, I'm taking a bigger number away from a smaller, that's negative. That's no solution. You just stop, write no solution, and move on with life. Okay? So this is 100. Don't forget your 10 out front. 10 plus minus. By the way, a lot of students forget that plus minus there. They do everything right, and they forget that plus minus. They put 10 root. So 10 plus minus 100 minus 64. Now some of you will just simplify that real quick and call it 36. You'll say, well, that's just 36 right there. That would be fine. Which becomes 10 plus minus, what's the square root of 36? 6. Okay, the root of 36, which is 100 minus 64, is 6 over 2. This is where we break it into two different problems. Okay, this is another calculator error, by the way. Actually, a programming error. For those of you that go, well, I'm going to go ahead and put 10 plus 6 over 2 and 10 minus 6 over 2. That's completely right, but then you do the math on it. You're like, okay, 10 plus 6, and don't know why we'd use a calculator, but we do. We just like typing or something. Divided by 2 is 13. What is 10 plus 6? 16. And what is 16 divided by 2? 8. It is not 13. Once again, your calculator is not wrong. The programmer is wrong.
Because it's doing 6 divided by 2 plus 10.
Good. It's doing 6 divided by 2 plus 10. Okay, you've got to put parentheses to tell it. Do this first, unless you decide to use this key. Now, many of you have no idea that this even exists on the TI-84s. If you go alpha, and then y equals, there's a whole nother set of menus that pop up. And this first one is your fraction button.
Whoa.
Now, when you put it in math print like that, it automatically reads that as 10 plus 6 in parentheses. They're implied.
Right.
Okay? You have to be able to go alpha, option 1, and then go 10 minus 6 divided by 2 is your second answer, which is 2. My hope is that you would not have to use a calculator for it.
It's not doing it.
Okay. Now, hold on one second. Let me finish this up. The answers are 8 and 2. Now, let me pause and help those with calculator issues. All right. I don't know. Hey, guys, let me point out why what's the thing I look for first? Come on, let's go back up here. What was the first one I try? After I determine there's a B, which there is, what's the first one I try? Factoring. Hey, guys, later in class, like tomorrow, I'm going to say you choose what method to use. And for those of you that like this method, that's fine. It takes a while, but please note, the method I always try first is factoring. And factoring, I just ask myself, hey, two things to multiply to make 16 and add to negative 10 are? 8 and 2. Yeah. X minus 8 and x minus 2. Well, this answer gives me 8. This answer gives me 2. That is much faster. Get you the same place. Factoring is the fastest. That's why I do factoring first. Can you get the same place? Yeah. But like I said, I mean, it's like going to Hagen's, but going I-5 to Marysville and then back this way to Hagen's. That's quadratic formula. Okay, going straight through the light and to Hagen's is this method. A lot faster. Okay? Hey. It's like going to Seattle to go to Canada.
I've never been
Right?
to Canada, so I've
Right.
never been to Canada. No, Timbits is the best part of Canada. We're supposed to go to Canada and California this summer.
Jeez. That'll be fun. You better get a passport.
No, you can do birth certificate, I think.
Okay, number 4. Give it a go. Are you talking,
just
Jonathan?
skipped
Or
2 and
what are you
3.
talking, Jason?
That's not right.
Yeah.
I go to Japan to go to Spokane.
You mean you go to Spokane to go to Japan?
No, I go to Japan to go to Spokane. I go there, and then I play plain black.
All right. Hey, try number 4. First thing you need to do, tell your neighbor.
Whenever I want to go to school, I take a plane to Vancouver and then Tokyo.
Okay, time's up. X, what do I do first? Add 13. I didn't want you to feel left out because you didn't have a neighbor back there. Okay, add 13. All right? Add 13. Kai's up here. He's being this Kai, not that Kai. Okay. All right. So, x squared plus 6x plus 13. I want you to start the quadratic formula, please. Get as far as you can on it. I'll be cruising around. The answer is no solution. How many are still cranking around?
I was.
Man, can't believe it. Okay, so here's my work. Please note on it. Look, 36 minus, this is a negative 52, so 36 minus 52 is negative 16. At that point, I didn't even have to write this. At that point, you could have stopped. It's no solution. Can't take the root of a negative. What's this negative 52, or excuse me, negative 16 called? Vocab. Look back to the previous page. The discriminant. Yes, the discriminant. Negative, not root negative 16, just negative 16. All right. Unbelievable. Number 7. Everyone take a look at number 7. It's on the next page, please.
We're skipping numbers.
Yeah, we're skipping some numbers, I'll agree.
Stop it.
Okay, number 7.
Oh, wait, what are we on? Number 7 on this page.
I'd like you to read it and draw a picture of what it says there, please. Best you can. Read it to yourself, not story time. Square pool has a side length of x feet and a uniform border. That does not mean it's dressed up. It means it's the same width all the way around. It's a uniform border. Okay? So it has a side length of x. So this is my pool in here. Okay? It has a border that is 1 foot wide all the way around. Meaning all of this on each end is 1 foot. The total area of the pool is 361. So the area inside here is 361. Each length is x. How do you find the area of, or excuse me, the total area of the pool and the border is 361. Okay? How do you find area? Length times width. Okay? So, if my entire area is 361, that includes this entire length right here. So what's this length?
X plus 2.
Yeah, that's x plus 1 and another 1, or x plus 2. Now, Gunnar, I know you're going to want that phone at lunch.
So 361 equals
Okay.
X plus 2 quantity squares.
This is going to be x plus 2 as well. So we got x plus 2 and x plus 2. You know what I think a great idea is? Like, if I take a phone, I should be like calling your parents from your phone.
That's a really cool
Be the
idea.
best, man. Like, hey, I just got this sweet phone from your, we'll say son at this point, and he really wants it back, but I need to meet with you before I can give it back to you. When can you meet? And the cool parent would say, like, if my parent did that to my kid, I'd be like, I don't know if I can meet with you for like a week. You know? That's all right. So, yeah, just keep that phone for a while. Okay? That is a great idea, man. Maybe we'll try that. Okay? So, from there, if we're trying to find x, which is the length of our pool, because if we can find the length of each side of the pool, then we can find the area of the pool. If we're trying to find x, we're going to have to get this all set equal to what? To 0. So, Keep going from there. FOIL might help.
What about the 360?
Okay, remember that right there. And set it equal to 0. Subtract that 361 from both sides. All right. There we've got it. Now, to solve for x, you have a couple options. You could try to factor, which is kind of difficult. Man, what are we doing here? You just forget that time? Okay, let it not be a habit. If either of you see his earbud go in his ear, tear it out, please. Take the little foam piece off the end and throw it up here. Goodness. He's like seriously in the Secret Service, like when you get older, just so you can have an earbud in all times. Okay. All right. So from here, tougher to factor, just because most of us don't know factors of 357. You could give it a go, but we do quadratic formula. So fill it out. Oops. Almost gave away what goes there. Don't want to do that. Takes away the fun. Forgot the negative. That's a good call right there. It's a mistake. You get a dum-dum. Way to be smart.
I get a dum-dum.
Yeah. All right. There's B. All right, hey, I'm going to go ahead and put up my work for it. You guys check it out.
Oh, I'm still.
Hey, what did we get? Not no solution. So we have our -4 plus minus 16 plus 400 or 1428, which is a positive number. That gives you the square root of 1444. Anyone get that?
Wait.
Wait.
Wait, sir.
Yeah, I got one.
You get that?
Yeah.
Cool. Which is 38.
Far too quick.
Far too quick.
I'm still
You still here?
about.
About? So that was a 4. This was a 1.
Oh no, I did that. I just
Okay.
didn't get to the part that you were.
And that was a 1. All of that stuff, this chunk right here, our discriminant, becomes 1444. Did you multiply it out? It's not 4. Notice right here, this is -4 times 1 times -357. That becomes plus right here. So that becomes 16 plus that. Yeah, so that's the first time we've encountered that where we've had a negative right here. A negative times negative is a positive. So it's 16 plus that. All right? So we end up with x equals 17. 17 times 17 is 289. Notice we throw out the negative because you can't have a negative length. Okay. Questions? All right. Hey, I want you guys to do number 8, please.
Dude, I need like so much scrap.
Okay, determine how many number of real solutions. Remember, you're doing this, right? These are your real solutions. All you have to do is b squared minus 4ac. So if you just determine a, b, and c.
I'm done yet.
I'm not done yet either.
Oh, okay. I'm not done yet.
Okay, you're just taking b squared minus 4ac.
There's 2 solutions? Or maybe it's 1 solution. I don't know.
Negative 4, negative 1, positive 3 is, that's 12. 36 minus 12 is 48. The value of the discriminant is 48. That means there are
2 solutions.
Wait.
Smartness.
2 real, oh, that's 36. That's plus.
Ha, that's what I was trying to say.
Yeah, I messed up on that. Should have put the plus. You weren't going to say.
Huh?
No, they was going to say, not you.
What?
No, not you. Them. Okay? All right, I want you to try number 11.
But that's not fair. I really was gonna.
Give number 11 a go.
Already did number 11.
Okay, on number 11, it's really asking the same thing, right? Because if it has an x-intercept, remember your x-intercepts tell you how many solutions. So when you're saying number of x-intercepts, you're really saying how many solutions are there. Okay, so you could do the same thing. Again, b squared minus 4ac. You can go this route. Now some of you choose to do another way on it. Anyone choose to do a different method?
I didn't factor it.
You just factored it?
Yeah, I factored number 11.
I tried to factor it. Okay. Good. Quinn? You graphed it? Okay. In this case, you get 28 is the value of your discriminant. Therefore, there are 2 x-intercepts.
Oh, wait, I have a question.
Oh, wait. I might have an answer.
Okay, so on the square root of 4, square root of b squared minus 4ac, is that 4 times a plus 4 times c, or is that 4 times a times c?
4 times a times c. Okay, last problem we're doing together as a class, number 14.
Okay.
Any method you choose. You can solve any way you want. Okay, out of curiosity, how many of you factored? How many of you used the quadratic formula? How many of you graphed? Anyone do completing the square? Anyone graph it on their calculators and calculate the zeros? Okay? So all of those methods are valid. In this case, I'm going to try to use factoring, which means I'm going to set it equal to 0, which you'd also have to do if you're using the quadratic formula. So subtract 16 from both sides. 2 things to multiply to make negative 12. And good. And add to negative 4 are negative. Nope.
Okay, well, I guess I know the math then. It's negative 6 and positive 2.
It is negative 6 and positive 2, as Kai is proclaiming. Way to proclaim it. Way to be that guy. Okay? That means this one, x plus 2 equals 0, so x is equal to negative 2. And x minus 6 equals 0, so x is equal to 6. No matter what method you use, you should get the same answer. Negative 2 and 6. Okay, for those of you who've forgotten the rules on factoring, this is a times c and b. 2 things that multiply, or the a multiplied by the c goes up here in b, and then your factors that multiply to make ac and add to b.
AC is nice when it's hot outside.
Good?